Yep, mic is working. Mic check, 1, 2. Okay, let's see if this thing is live and running. Seems to be good. Now let's see if the live chat is working. So if you have just joined in, say something on the live chat. I want to make sure that my little live chat window actually works at the moment. Ah! Fantastic, yes, live stream, the chat window is working. Fantastic. Hello guys! Afternoon! From the UK, it's a baking, check this out, right? It's a 37 degrees Celsius here in the UK just now. I don't know what that is in Fahrenheit, because that's not me. But yeah, 37 degrees Celsius over here in the UK today. Absolutely roasting hot. I'm actually very glad that I don't have a full head of hair anymore. Very nice to have this nice, quick radiation of heat away from my massive head. Yeah. Holy shit, 38.2 in the Netherlands. That's crazy. Fuck yeah. Like Europe is baking at the moment. It's pretty crazy. What's your opinion on the Orion HCCA, Orion, however you want to say it, HCCA amplifiers, says Tech Fanatic. The old ones, the D2400 and the 5000 are sweet amplifiers. Beautiful, well designed, underrated amplifiers. Fantastic. However, the newer HCC amplifiers, the full bridge Korean boards, are not so good. They do good power for the money, but they have a design flaw, and the FETs are not driven properly, and they run warm on idle, and also they do not like being in parallel with each other in the circuit that they're in. So the new Orion HCC amplifiers I wouldn't touch, but the older stuff, yeah, very nice. Norway only 29. Well, it's still bloody hot, isn't it? That's still bloody hot. Aaron says, thanks for the help before. No worries at all, my man. Right, so who the hell has seen this brand of amplifier before? Who's seen this before? I've never come across this brand before in the UK. Maybe it's a European thing. Looks really nice though. It's like it must be a custom tooled heatsink. I've not seen this heatsink design anywhere else before. You've got this kind of grills on the side that are pretty cool. Although they will rattle if this is mounted anywhere that has any slight vibration. This will rattle like a bitch, and that will drive me insane. Crossfire, I've never come across Crossfire in the UK, so I can't comment, unfortunately. Did you see my question on Facebook? I haven't been on my Facebook page yet. I've been out for a drive to pick up a bicycle for a friend, so that's where I was, so I haven't been on my Facebook just yet. Literally came back home the second I walked in the door, workshop clothes on, and amp on the bench. I haven't even logged in back on my Facebook yet, so no, haven't seen your question just yet. Almost reminds me of Orion. Yeah, it's that sort of colour, isn't it? Right, so I bet other people are curious to see what the guts of this thing looks like, so let's pop her open and have a look. Now this amplifier doesn't have the traditional screws along the back here. What we have to do is we'll have to remove one of the end plates, I assume, in order to gain access under the case here. So let's go ahead and start taking this baby apart. Oh no, I don't think those, not those screws. So these screws over here are just for the mounting feet, so let's put that one back. I assume that was something for the end plate there, but it's actually just for one of the mounting feet. Let's put that back in there. And so to take this thing apart, we're going to have to go ahead and take one of the sides off. So the side that is easiest to take off is probably going to be this one, as it has the least number of screws in the board, because it's just the RCA side. So let's go ahead and take our Allen key here. Marion says, I also have a STEG that I have a small problem. It works on 12 volts when my engine is off. When I start, my alt push is 14, amp goes into protect. That's possibly actually just a protection circuit fault. I have seen that before on some amplifiers, and it's a leaking protection circuit transistor, and above a certain voltage the leakage becomes enough that it triggers the protection on the TL494 chip. So it might be something very simple. There might not actually be a problem with the amplifier. There is a risky way to check that, of course. You can disable the protection circuit and run it on 14 volts and see if it explodes or not. That's obviously a risky way of doing it because you could cause more damage doing that. Obviously that's in the car. If you have a current limited supply like I've got here on the test bench, you can give it 14 volts and you can limit the current and you can monitor the circuit as you turn it on, so you can disable the protection circuit and see whether the amp is actually happy at 14 volts, and if it's not happy, then obviously the limited current supply will save the amplifier from any further damage. I've shown you what was already basically this amplifier actually belongs to a guy in the live chat with us today. I was trying to pronounce his name earlier. I want to say it's like Gian. Let's all call him Gian, okay? Because that's the way I pronounce the G's in the UK. So we've got Gian here in the live chat, and this amplifier belongs to Gian. So we have the customer viewing our repair today, which is always fun. So he says, I've shown you what was already done with this amplifier. I sent you a document already with the replaced parts. What was wrong with it? Yes, that was a while ago, so I have completely forgotten what the replaced parts were. If you have that information handy, then just remind me quickly. Otherwise, I'm sure we'll get to the bottom of it in a short amount of time. So this should technically slide out, but it's very stiff, so... okay, let's get some pliers and a towel because I don't want to scratch the case here. So get some pliers and a towel, put the towel in there, grip it with the towel. Oh, it's too slippery. Let's get some better pliers. There we go, that's how it's done. Okay. So, pretty cool. So as we can see, the board is a lot thinner than the amplifier case suggests. My scope cam has fallen. The board is actually thinner than the case suggests, and that is because we've got some good heat sinking going on here. These grills will obviously... Oh yeah, look, they slide out here. And you've got little fans in there. That's a really nice touch. That is a very efficient way of cooling these MOSFETs. I like that a lot. Very good design there on the heatsink. Like it. Nice. So let's have a look. What have we got? We've got these inductors appear to be on sister boards that are raised from the main board itself. I'm going to take my zoom in camera here so we can just have a look at that. So let's give that a clean. Tech Fanatic, the Orion amplifiers, by all means run them for a while, but just be aware that they can spontaneously die on you for no reason. So some of them will be alright. I'm going to explain the faults with these Korean full bridge amplifiers in another video soon, and some of them will be alright and some of them won't be alright. It's all just pot luck as to how they were made in the factory and what FETs they were given. So by all means, if they're running okay, then continue to run them. Just be wary of when they get really hot. Yeah, just be very aware of when they get really hot. They don't like that. So this is something I've not seen before. We have the inductors and it looks like they're either on sister boards or they're actually, we've got these insulated kind of pieces of board here that are preventing them from touching these rails for the power supply, that is. So the power supply comes in here, the power supply comes in and the ground on copper rails, which is pretty nice, goes into the board, which will then go onto the power supply MOSFETs. We've got the power supply transformers here, I assume, which are pretty compact. and then these will be the rail inductors to smooth out after the switching. We've then got the rail capacitors here, which will store up the rail voltage. We then have the main output inductor, which looks seated down pretty well. And over here we have part of the drive circuit and the voltage regulation. This will be producing plus and minus 12 volts or 15 volts plus minus 5 volts, etc. For the drive circuit. And I assume the drive circuit is probably on here. Yeah, we've got some ICs. Look like they may have been rubbed off a little bit. I'll get the, oh no, there we go. So we've got some ICs that I have not seen before on here, which is fair enough. Okay, cool. So we're going to wait for the information from Giant to come through on Facebook. He's going to tell us what the issue was with this amplifier. Then we'll get started on looking to see if we can sort it out. Okay, let's have a look on the live chat. Amplifier came in with a defective Class D amplifier and power supply. When testing without a load, normal output up to 55 volt RMS unclipped. When testing on 4 or 2 ohms loads, the output signal is clipping asymmetrically at 16 volt RMS. At 1 ohm load, 9 volt RMS, no protection. Power supply is plus minus 75 volt rails. So already replaced the power supply part 16 times 80 NF55, which will be the power supply MOSFETs in here. 16 times 30 AC06 rectifier. Okay, that'll be these ones here, D4, D16, D17, etc. And times 2 MIC 4422 gate drivers and 1 SG3525. Okay, so the 3525 is a bit of a nightmare chip. I don't like working with that one, but hopefully the power supply is okay. Sounds like we just have some output section issues here going on. So let's power her up then, and let's confirm that this amplifier does what Giant is claiming it does. Already replaced Class D parts 2 times, so it uses the same, similar gate drivers in the output section, MIC4421, 2 times L0600 optocouplers. Was all of this stuff dead? Like, usually the optocouplers are okay. 12 4228 MOSFETs, and 12 of the small transistors, original SMD, it's 2 Fs, 2 times 18 gate resist, 18 ohm gate resistors, and a comparator. So basically this has had pretty much a full rebuild. So yeah, okay, interesting to see what it's doing then. Let's find the right size of Allen key to go in here. Okay, and the last one, the remote. The remote goes in on the other side of the board. That's a pain in the ass, because my remote wire I don't think will reach around there. Okay, let's see if we can reach it. Okay, yep, so the remote goes in over here. I'm just going to wrap the remote wire around this little pin here, so it stays in like that. Right, okay, let's crank her on and let's get some signal going in. Give me a sine wave to see what's going on. So I wonder whether this is bad or good without a load, first of all. Let's get my frequency generator up here. Okay. Right, let's give her some power and see what happens. So we have a phase flip LED on, protection light, cool. Let's probe the rectifier just here and see stuff come onto the screen. There we go, so we can see the wave is starting to build there. Okay, so the amp is straight into protection. You can see the protection LED over here. So it goes to turn on, and instantly there we have protection. So let's just check the rail voltages. So rail voltage up here, looks like we have VCC plus, VCC negative. So okay, I think it's now turned on. It's now staying on, but it's staying on with a very interesting looking wave. This is probably a modulated wave, so it won't be going full pulse width modulation on the power supply just yet because it's not got any load on it. There's something weird's going on with the rails and my scope. It's a bit strange. It's almost like my scope can't read the rails properly. I may actually need to clamp my scope. I don't usually have to do this, but I may have to clamp my scope on the output section ground rather than the power supply ground in this case. Yeah, there's a ground potential difference here. Okay, so let's clamp my scope onto the output section ground instead. And my scope ground probe is very small, very short, which is very annoying. Okay. Let's get a long piece of wire and ground my scope to that. Greetings from Germany. How's it going, buddy? Greetings from the UK. Is it as hot in Germany as it is in the UK? How hot is it in Germany right now? Whoa! What the fuck? Scope, ground. Maybe it touched the VCC slightly. That's fine, that was just the capacitors discharging there, so through the ground. So let's take our, so this should work now. So I should now be able to read, that's better. Okay, so I can read the rail voltage properly now. So yeah, this amplifier, interestingly enough, the output section ground and the power supply ground is very isolated from each other. It's very uncommon. I rarely have to do this where I have to ground the scope to the amplifier's output section ground rather than just using the main power supply ground. Very unusual, but okay, it goes to show this is a completely separate, unique board design, which is nice. So let's get her powered up fully again. There we go, we have green, we have operation now. So yes, we have 75.9 volts, just what Giant was saying on that one, and on the negative rail we have 75.5. So yeah, pretty much balanced. So let's just check the output section stuff around here. So we've got the output FETs over here, so we should see a nice drive wave, etc. going on. So that's the high side drive, and that should be present on both sides. And then in the middle we should have just the positive rail, which we do. And the low side, let's see, is the low side over here or is it on the other side of the board? It's on the other side of the board. So there we have the low side gate, which looks very nice. Let me zoom in on there for you. Where's my... here it is. So yeah, we have the high side drive like this. Looks very nice. Low side drive looks like this. Also very nice. Looks nice. It's a beautiful shaped low side drive actually. Let's zoom in on that just for you guys to see this. This is a nice looking low side drive. Very pretty. Very nice shape. That's turning the FETs on and off nice and quick. Beautiful. Right, so at first glance, it doesn't appear to be any drive faults so far. Let's check the other outputs here. Let's just check the drive waves on those. Is the same as what we saw just a moment ago. 70 volts worth of drive there. $70 worth of drive. So that all seems to be a-okay. So let's now feed this with some signal and see what the output sine wave looks like. Because that's what the issue is apparently, is that the output sine wave does not look very pretty. So let's get a small screwdriver. We're going to turn the gain down first. Okay, and let's probe the speaker outputs, which are over here. And let's see what the sine wave looks like. There we go. Okay, so let's turn her up and let's find our clipping point. Now we're drawing 2.4 amps, as you can see on the small camera over here. Let's just put that over just a touch so you can see that a little bit clearer. Let's turn it up and find our clip point. So this is a half bridge amplifier. Drawing a little bit more current now, 2.7. Okay, there we go. That's where it starts to clip, and we draw about 3 amps. So it starts to square off there, as you can see. So yeah, the sine wave looks beautiful without a load attached. So what we're going to have to do is we're going to have to attach a small load to the amplifier and see if that changes things. So let's get my dummy loads over here. Now I won't be able to turn it up very much with the dummy loads because I've only got the 20 amps worth of power supply here to play with. So let's give it a 4 ohm load, just something nice and, you know, a higher load to drive so we can get the output voltage up a little bit without drawing too much current. So let's bring this over here. Needs a very, very small Allen key on the speaker terminals here. Let's try and find where my baby one has gone. Where's my baby Allen key? That's a bit too small. There we go, there you are, my friend. Okay, so let's bring that back, plug these in. Okay, cool. So now we have a 4 ohm load hooked up. So let's turn it back on and let's start slowly turning up the input level and seeing what the sine wave does. Now for this I'm going to give the power supply full reign of its full 20 amps, or around about 19.8 amps that it can provide at this voltage, and yeah, we'll see what it can do. Okay, so power on. We're going to want to probe the speaker output actually. So if I go over here and probe the positive speaker output, which is this one here. Oh yes, my current amplifier is still DC audio 10K from earlier. My bad. I need to change that. Let's get back in the habit of changing that. Let's change my current amplifier to STEG 5K. Where have you been the last while? I've been very busy. I've been doing lots of amp repairs. I just haven't been live streaming them because my computer's not been in this room. It's been upstairs. It's always a mission taking it back and forth. Okay, cool. So everything's hooked up now. Let's turn this back on. See what the sine wave looks like driving. This is a 4 ohm load that we're driving just now. Okay, so we've got 2.3 amps. So let's start the sine wave and slowly turn her up. And you can see the current draw getting bigger. 3.8 amps, 6, 7, 8, 9, etc. 10 amps drawn. Okay, so that's the limit of our power supply, the 20 amps there, which is why it turned off. So let's turn it back on. So the limit of our power supply is about 20 amps. So let's just hold it. Let's hold it at about sort of 15, 16, 17 amps here. Sine wave still looks beautiful, so I'm not seeing an issue there with the sine wave. Still looks very nice. We've got 27.2 volts RMS on the output there. So yeah, sine wave looks really nice. The amplifier does have an internal fan. Yeah, it has a couple of fans on the inside the side panels. So you see this amplifier has a couple of panels in the side here. There's fans inside here that blow air onto the sides of where the MOSFETs are clamped to, which is a really nice way of doing it. I like that. Right, so yeah, the sine wave still looks really nice. We don't seem to have an issue with the sine wave there. So I'm quite confident that this amplifier is not going to explode if I bench test it. So what I'm going to do now I've confirmed that there doesn't seem to be any drastic problems here, I'm going to go ahead and plug her into my Dell server power supplies and bench test on full power and see if the wave does what Giant here is saying it does. Okay, let's go over to Facebook and check the image that Giant has sent me. I haven't checked that yet. Let's have a look. Okay, so this is apparently what the amplifier is doing. So that's what we need to look for. So I haven't found it yet, and let's see what it says. It says, when testing without a load, normal output up to 55 volt RMS unclipped. When testing on 4 ohm or 2 ohm loads, the output signal is clipping asymmetrically at 16 volt RMS. So I didn't see that just then, but I got higher than the volt RMS that is quoted here on this test. So let's go ahead and plug in the big supplies and see if we can make the amplifier do what we just saw on the screen. So these power input terminals are pretty small. I'm not going to be able to fit I don't think I can fit my 70mm cables in there, but we'll try. This is supposed to be a 5K. I really would like to see bigger power terminals on this, as I really don't think, yeah, there's no chance of getting my 70mm cable in there. So we're going to have to hook her up with my 4 gauge, and there is quite a significant voltage drop across my 4 gauge cable. So this will limit the power that this is going to do. Yeah, this has literally got 4 gauge inputs. The 4 gauge fits absolutely perfectly in there. A tiny bit bigger and it wouldn't go in. That's what she said. So this probably isn't a 5K amplifier, is it? This is probably a 2.5K amplifier that's 5K max. So I wonder what this will bench. This will be interesting to see. Now I need my long ass remote cable, because the remote needs to go all the way to the other side of the amplifier board. There we go, this will do. It's not long enough still. Need a nice long bit of wire. Where have I got a nice long bit of wire? Maybe I'll just attach 2 nice long bits of wire together. Oh yeah, 0.5 it'll probably do fair power. Bench testing 0.5 is always risky. Because a 0.5 bench test is a bit like running the amplifier at 0.25 reactive. So yeah, to do a bench test of 0.5, it's very, very hard load on the amplifier. It is a bit like running it at 0.25 on a woofer. It's actually rated at 0.5. Ah, okay, cool. I haven't checked out the ratings of this yet. Well, if it's rated at 0.5, then we should have no problems doing a 0.5 test. But we're going to stick with a 1 ohm test for the time being, because it's a bit safer and I have to get my 0.5 loads out. And if the 1 ohm bench test looks okay, then I'll stick it on the 0.5. Okay, so all our loads are hooked up now. All our dummy loads are hooked up in the amplifier. I'd quite like to flip this over and be able to probe the circuit if I can. See, yeah, that looks good. We can do that. So now let's get our remote cable. How's your lady friend doing? Yeah, she's pretty good. And she is just a friend, very much so. We are not compatible in that sense. But she's a very good friend of mine. Really good fun, really lovely person. I actually went and got a bicycle with her today. She wants to start riding her bike again, and I went and found one on the Facebook Marketplace local. Went and grabbed it in the van, listened to some music. It was pretty nice. That's where I've been this afternoon after my DC Audio 10K repair. Went and picked up a bicycle, came back and doing another repair. Right, we're all hooked up on the power to test this out fully, so let's go ahead and put our RCAs back in. Get our screwdriver bit ready for the gain knob. There we go. Get the phone turned on. I still have one of the Explods, yes. I use it daily in the Proton for the time being while I'm waiting for it to be finished. Sounds lovely, actually. Alright, let's get this baby fired up then. So, yep, remote goes in there, yep, power, ground. Just because we've got Giant watching live, I'm just double checking every single thing I do. Power that up like so. Get our scope probe ready. Okay, let's go. Cool, she's all powered up. I'm scared, says Giant. Yes. Right, okay. So let's start a tone. Now I haven't grounded the scope onto the amplifier just yet because the scope and my main power supplies do share a common ground, and I don't necessarily want to connect the two grounds if they aren't meant to be. So I'm going to try and do this first of all without connecting the grounds together, because maybe that doesn't want to happen. So let's start off with playing a tone and let's see what happens. There we go, yep, on the screen there we can see the tone starts and it reads it perfectly fine. So yeah, let's start slowly going up and start looking at what the wave looks like. Ah yes, so here we have the issue that Giant was telling us about. Doesn't look very good, does it? Okay. So what we want to do is we want to take our probe, and we're going to need to look at the amplifier's output section whilst it's running on the big supplies to try and figure out what's going on here. I would rather not do this whilst running on the big supplies, because if my finger slips and shorts something out, then there's no current protection here to save me. So is it the low side drive that causes that issue, or is it a high side drive fault? So let's zoom in on the low side drive here, and we're gonna get this DC offset because we're not grounded properly. That's fine. So this issue appears to be coming from the driver board itself. So I'm probing the driver board here, and the issue does appear to be coming directly from the driver board itself. See that there? So that little dip there in the drive waves is the problem that we're seeing here. And that's on the high side drive. Let's have a look at the low side drive. It's also on the low side drive. Okay, let's turn her off for a second and let's have a look with our thermal imaging camera and see if anything on the board is heating up that it shouldn't be. Okay, so the whole driver board is you know, it's warm, it's 42 degrees, which is acceptable. We don't seem to have one area any warmer than another. Voltage regulators, as to be expected, are warming up. Nothing seems hotter than it should be, so it's not something that's shorted and heating up. Let's turn her back on and let's continue looking at these waves all over the drive board, I think. What I might do though is I might actually disconnect my big supplies, put it back on the small supplies, but leave the 1 ohm load hooked up. Because perhaps this is only happening on the smaller 1 ohm load, on the lower 1 ohm load, and I can get away with still using my current limited supply to do this on a much safer level than I am by using the big supplies. So I'm just going to flip this back over and I'm going to change back over to regulate the small current limited supply. As I really don't feel comfortable probing around in here with 350 amps on tap. What is a should-be temperature for inductors on a 400 watt amp? Well, like 32 degrees after a while, 35, maybe 40 at the tops. It shouldn't really be that hot. Where can I buy coils? If you mean inductor coils, you can't really. You just have to rewind the ones that exist there. You have to buy the copper wire itself and rewind it. Right, okay then, so I'm just going to test the tape off this ground wire because I don't want this to touch anything inside the amplifier. Okie dokie. So let's turn this back on, let's turn my DELs off. Let's turn my current limited supply back on. Okay, now let's see what level of sine wave we need in order to make the amplifier do the issue that we were experiencing, but on this small supply. So let's turn it back on and let's see what goes on here. Okay, looks like we might need some pretty big current here, so let's go up and give it 16 amps. Okay, there we go, there's the issue. 8, 9 amps. You can't see that. There we go. Okay, so when it does that, it draws a shitload of current. So yeah, the amp is not happy whilst it's doing that. It draws a shitload of current. Okay. The amplifier will get pretty warm quite quickly as well because it's drawing quite a lot of current in order to do that horrific nastiness. So I'm going to remove a couple of the dummy loads here so that it's not driving a 1 ohm load. I'm going to give it a 1.33 or a 2 ohm load, because what I want my current limited supply to be able to drive the amplifier whilst it's doing that weird issue, so I can probe around on the board and see what the issue is. So let's remove one of the dummy loads to take it from 1 ohm to 1.33 ohms. It's probably not going to make a whole deal of difference. Okay, there it is. I think we're going to need a 2 ohm load instead. Let's remove that other. Damn it, I can't get the current limited supply to actually give it what it needs in order to get this to show the issue. I'm going to turn the current limited supply all the way up to 20 amps and see whether that helps. I really don't want to do this with the big supply. There we go, there it is. When this happens, it draws about 20 amps when that happens. Okay, cool. Right, that's about where we need to be in order to present the issue, and I can actually, yeah, the amp gets pretty hot. I'd be interested in which FETs get hot. That would tell me more about the amplifier's status of health. It appears to be this side of amplifier is getting warmer than this side, so I would say the issue is on this side of the board. But I would probably need to remove the MOSFET clamps and make it do that issue just for a split second and see which FETs get hot. That would tell me more about what's going on here, I think. Right, anyway, let's have a look, and let's look at the inputs then of this amplifier, and let's see all the different waves going on over here. Alright, so the input here has the input sine wave coming in. And we have positive there, so let's have a look at the high side. That has the issue. ground, low side. Ah, okay, I think I found the issue. Oh, I thought I had. I moved the inductor and it didn't make that noise anymore. Damn it! I thought I found the issue just then. Oh wait. I thought the issue was the inductor, but perhaps not. Okay, no, it's definitely must be a drive issue, but it's very strange that it only does it with a load. If the drive was bad, it would do it without a load. So this side of the amplifier is getting very hot. So it's this side of FETs that's the problem. So I could go ahead and just replace the driver and the. I could just go ahead and replace the drivers and stuff on this side of the board again, just in case that's a problem here. The issue seems to be more with the low side drive than it is the high side. So this is our low side over here, and this is our high side over here. Yeah, it comes directly from the driver board. Right, the thing that we want to do here is we want to compare what's different when there's a load attached and when there's not a load attached. I think that will tell us some things about what's going on here. I do think that will tell us about some things about what's going on here. So on the driver board here we have some pins which are labelled 1, 2, L, G and H and SD. SD I assume is shut down. We have low gate, so we have low, ground, high, and then 1 and 2. I don't know what 1 and 2 are. So on the board here, number 1 has a version of the sine wave attached to it. So if we do that, probe number 1, we have a noisy version of the sine wave. And number 2 doesn't seem to have anything on it at all. It's like a kind of ground. So I wonder if we remove the dummy load, does something happen on number 2 that's not happening at the moment? Also, I wonder what this potentiometer is. It says dead time. I'm going to have a play actually. I'm going to just try and briefly move that ever so slightly as we play the amplifier and see if that changes our results at all. In order to do that, I just want to actually clamp this onto the speaker output so I don't have to hold it with my hand. Doesn't really appear to do much other than just draw more current from the supply. So it's not actually helping us here. Okay. Ah. Now what's that? So this has that DC pulse on it. Now what part of the drive board is that? Okay, so that nasty wave is coming out of this chip. It appears this chip is, I can't see that labeling. So the chip that's coming out of is OPA 2134UA. So that little bit of clip square wave there, I've just located that on the drive board, appears to be coming out of pin 1, 2, 3, 4, 5, 6, 7 of this small chip here. It's either coming out of it or it's going into it, but it looks like it's coming out of it. So we have a sine wave here, which looks like it may be going in. And then over here we have this nasty looking thing coming out. That's interesting. So what I'm going to do is I'm going to disconnect my dummy loads, and now I'm going to compare what we see on that part of the driver board with the dummy loads disconnected, and see whether it should be a nice big square wave or something like that. Alright, so the dummy loads are now removed. So let's go ahead and let's see what should in fact be on that pin instead of that clipped bit of square wave that we see on the speaker terminal. So let's go ahead and probe that pin again. Okay, so we should just have a sine wave that looks like this. See there, we should just have a sine wave that looks like that. If we zoom in on that, you can see it's a very, very small amplitude sine wave, but it shouldn't have any of that nasty stuff going on. So I wonder whether it's worth replacing that chip and seeing whether that resolves our problems. It's definitely, I believe, a driver board fault here. Because it doesn't do it at all when there's no load. Does it? Ooh, hold on a minute. What's up with that? Should that be a nice big square wave? I don't know. I don't have anything to compare this to. Or is that just a ground? So that's a nice big square wave. I'm just checking the square waves on every single one of these pins. I'm just looking for like an inconsistency. And I think we can see there is one inconsistency somewhere, isn't there? Yeah, that's modulating with the wave, so I reckon that should be a proper square wave. I think that might be what our problem is here. So we've got a couple of chips here that I think I want to replace. A couple of chips here that I want to replace, and that might or might not solve our problems. It could also be a bad capacitor along here. So the board's powered down. I'm just going to do some quick checks with the multimeter. It's getting quite complicated with what I'm not going to fully explain what it is I'm looking at just now. I'm going to be here all day. I'm just going to do some checks with the multimeter. Right, so that's going somewhere else as well. So what's connected to this? Yeah, I think these should be proper square waves, if I'm being perfectly honest. Okay, cool, right, so I think I know what I want to do. There's a few chips on the driver board that I want to replace, so I'm going to have to order those and swap them out and go from there, I think, before we can go any further with this. Cool, okay. Okay. Let's have a look in the live chat. Addy says that you're alive. Hope to see you more often. Yes, I'm going to be doing live streaming a lot more often now. Hi, the GZ amp that you helped me with still works after the 494 chip bridge wires cut. That's really interesting. So you just kept going into protect, and now you've managed to keep it out of protection. So as long as it doesn't go back into protect again, I think you're probably really good. Unless the TL494 has been damaged and therefore it's not going into protect anymore because it's damaged. Yeah. Yeah, I want to make a 32-inch woofer, yeah. Well, they don't make it, they put their sticker on it. Good evening, good evening. Right, so, yeah, this STEG, I have had a look at the drive circuit. It seems that we need to purchase some replacement chips for the drive circuit, so I'm going to go ahead and have to order those now. They'll probably arrive next week, so I will then swap those chips out and continue with the repair. It's one of those ones where the issue is when it's driven by a load, and the issue is all the way back in the feedback loop, so it's very difficult to kind of find where it is, and it's even more difficult because I can't see where the issue is without a load being driven. This side of the amplifier only is heating up a lot, so these FETs, it's the drive wave being sent to these FETs that's not good. This is the high side. So it's all of the high side FETs that are getting hot. The low side FETs are staying cool. So it's something on the high side drive that's the problem. So we could just trace back through the driver board the high side drive output and change the chips that that's connected to. I think that's probably what we'll do. It's very odd that it only does it when driving a load though. Yeah, cool. So I think that's about as much as I can do on this amplifier today. Order some new parts and go from there, I think. So, yeah, I'll order those parts, and when we get those, I'll start the live stream up again for this amplifier. But until then, I think I'm going to go and grab some food and have a drink. Yes, Henrik, I did start live streaming again. I'm going to be doing this a lot more often now, so... Henrik, unfortunately, you've joined me just at the end of the stream. I'm going to lock off the stream in a moment, go and grab some food. But I might continue the stream a bit later on this evening. I've got a few amplifiers to look at, so I'll probably continue this a little bit later on this evening with some other amplifiers. And then when the parts arrive for Giant's STEG amplifier here, I'll continue with that on a different day when the parts arrive. So yeah, guys, cheers for watching, and I'll probably see you if you stay tuned on the channel. I'll probably do some more live streaming a little bit later this evening with some different amplifiers, so stay alert on my channel if you want to catch me a little bit later on today. Until then, I'll see you later.